you can hear me okay? Yes. Thank you for the opportunity to talk, and in the outset I'd like to acknowledge the Calperum Station near Renmark, 20 kilometres north of Renmark, where we carry out all our research, and they've been involved with us for many years, and they're always very ready and willing to support us and help us with projects, and have been great collaborators with the University of Adelaide. So when we talk about natural capital, we are referring to the stock of living organisms and the biological, physical and chemical systems that support them and the services they provide. We know that those who manage their natural capital well, their soil health, water, energy and biodiversity tend to be more resilient and more productive over time. These are the words of Ken Henry, National Australia Bank Chairman, speaking about natural capital in 2016. In this talk, I will illustrate the resilience of the Calperum Mallee after bushfire using ecosystem measures by the TERN Calperum Osflux Tower and measures of natural capital in 2015 and 2017 by National Australia Bank employees and Year 10 students partaking in Earthwatch Institute expeditions. So at the whole ecosystem level, there's an avenue for applied science. So net ecosystem productivity is directly measured by the TERN towers. It is positive if the land is gaining carbon dioxide or sequestering carbon dioxide, or negative and termed the net ecosystem exchange if the atmosphere is gaining carbon dioxide. Natural capital is the net primary productivity and is the ground component of the net ecosystem productivity. TERN Osflux is a network of towers providing nationally consistent observations of energy, water and carbon exchange between key Australian ecosystems out in the atmosphere. You can see Calperum is one of the active sites located in South Australia, and these towers record observations every 30 minutes and they span back several years, and our data is global, where our data is joined with towers from other countries in Europe and North America, and our data feeds into NASA. This is a particular project called EcoStress, which will be beginning in June this year, where satellites are measuring the temperature of plants, and our towers will be used to ground truth the observations that the satellites are recording. So to show you some pictures, on the right is the Calperum Osflux Tower. It's 20 metres and is recovering from a bushfire in 2014. And on the left is Warra Tower. This is in the south of Tasmania, and it's 80 metres tall, and there's a mix of trees there that are 70 years old and trees that are greater than 250 years old. So at the ground level, the Calperum Tower has data since 2010, and from looking at this graph of the net ecosystem productivity, you can see that since 2010 the site has been recovering from the millennium drought. So this is before the bushfire, and it was sequestering carbon dioxide at about 1 or 2 tonnes of carbon per hectare per year. And then the area suffered a bushfire in 2015, and since then the site is recovering from the bushfire, and in 2015 and 2017 is when we had National Australia Bank and Year 10 students working with us to measure the natural capital on the ground. So in this picture you can see the National Australia Bank employees in 2015 measuring the leaf area of entire canopies. The leaves were fed along the conveyor belt and they passed under a light source and were able to work out the leaf area, and we had several trees that we chopped down, and they had to measure the weights of the leaves, the twigs and trunks and the debris, and we worked out ratios of the leaves to the twigs and to trunks on unburnt trees, and that was from unburnt trees and leaves to regrowth stems and burnt trunks of trees from burnt areas. So here I'm showing the numbers of the leaves that were measured of the trees, and the numbers are down a bit in 2015, and that's because we focused on the proportions of stems and twigs, and so there was a lot more work involved there to be able to use this logarithm to calculate a dry mass from the trunk diameter at the base. And the results are we worked out the natural capital from actual measurements was 55 kilograms per tree, and from measurements of the trunk diameter at the base over a hectare, and using this above relationship we calculated 44 kilograms per tree. So we're in the right ballpark, and we may be able to improve this in the future by measuring trunk diameters from an unburnt hectare. So the results so far is the annual gain is 1.6 tonnes of carbon per hectare above ground and 0.75 tonnes of carbon per hectare below ground. At 1 year and 3 year time points, carbon in this ecosystem has remained steady at about 85% of unburnt mallee, and 15% remains lost because of burnt trunk breakdown. And so we can predict a 6 year lay period followed by 17 years of solid growth, 23 years agreeing with decadal restoration timescales. At the leaf level, there's an avenue for fundamental science. After 3 years, leaf mass per area density and water content are similar already to unburnt leaves. After 1 year, the leaves were thicker, had higher relative water contents, and were not as dense. So already the canopy area of the regrowth stems is already 3 years after the fire is already back to the same area as unburnt trees, and there are more leaves per tree, and it will be interesting to follow thinning out of regrowth stems and if more leaves grow on remaining stems to maintain the canopy area. So to conclude, the Mallee illustrates resilience of natural capital. I borrowed this philosophy from the Wentworth group of concerned scientists, where they have programs of natural capital that we have to measure our natural capital to work out how to manage it. And Rosemary also mentioned similar philosophies this morning. You'll have to let us know if you'd like to join us in 2019 as we continue these measurements. I'm also interested at the state level, and also Sarah sort of mentioned this morning, if we have these ecosystems, the possibilities of carbon onsets and carbon offsets, and the value of these ecosystems. And this state has emerging projects. Like in the lead up, I've been reading about the Charleston Conservation Reserve and how that's going to be turned over to the regulator. So there's all emerging fields that we'd like to be involved with, and if you'd like to be involved with us. And I'd like to thank the workers that worked with us in the field. We get through a lot of work that we wouldn't be able to achieve on our own, and we also have been enlightened to the concepts of business, and that has been good too. So thank you.